Welcome everybody to our DSL summer school. So I'm gonna talk a bit more about the DSL platforms that Martin mentioned. Just a few words about myself. So I'm Tiark Rompf. I'm an assistant professor at Purdue University since last year, and you probably don't know where that is, so I have a little map for you. So it's a little bit down off Chicago there. So back to our DSL platforms. Obviously, everybody in this room agrees that, well, DSLs are an important topic, and sort of we should build DSLs, we should work with DSLs, and we should do research on DSLs. So now the question is really, so how do we build these DSLs, right? And if we accept the premise that, well, we want DSLs, then that also means that we need many of them, right? Because DSLs are by their nature domain specific. Right? So for each new domain, we need a new domain-specific language. So the question is, how can we do that? And so one important direction here is language workbenches. Right? So this is an approach for external DSLs, right? So where you have a custom syntax and custom infrastructure. And of course, if you develop these external DSLs in a traditional way, then that's a very large effort, right? You need to implement a compiler, which includes a parser. You need to implement debuggers and profilers and IDEs. And the idea of language workbenches is really that, well, you need to streamline this process, right? So we need tools to build languages. And one example of this category is the SPOOFAX language workbench, which Elko is going to talk about. Elko, can you just stand up? Yeah, so that's Elko. And so SPOOFAX is one of the most advanced of these platforms. And really the cool thing about SPOOFAX is that it's built around a set of meta-languages, right? So it takes a DSL approach to build new DSLs. So there's a language for name binding, there's a language for syntax definition, and also for type system definitions. And from these programs in these DSLs, you can essentially synthesize whole IDEs and debuggers and tool sets that lets you build new DSLs and write DSL programs. So another aspect of external DSLs is that, well, you want to have them run fast, right? Or about languages in general. So this is one other talk we will have this week by Thomas Wöttinger. Thomas, can you stand up? So the platform is called TRUFFLE, and it takes the ideas of just-in-time compilers as they exist in like the JVM or in Google's V8 JavaScript VM, and makes all of that programmable and makes it much easier to develop new high-performance JIT compilers for new languages, right? For existing languages, but also for new ones, right? So you can imagine a DSL that is built on TRUFFLE and automatically inherits specialization and dynamic compilation facilities from the underlying platform. And the way this works is that essentially you just implement a high-level AST interpreter for your language, and then you define a few specializations, right? So your interpreter can do a bit of profiling, right? So you can sort of profile what kind of types you see in your program, and then you can rewrite the program with more specialized nodes. And what the TRUFFLE system will do is it will take these specialized nodes once the system has become stable, and it will turn these interpreter trees into very fast compiled code using a partial evaluation approach. Right? And using that method, you can implement fast and state-of-the-art just-in-time compilers with very low effort. So another angle to DSLs, instead of starting with a custom syntax and like a custom tool chains, as Martin mentioned, is DSLs embedded in another language. And here the question is really, well, how does one integrate a domain-specific language into a host language? And so we're going to have a bunch of talks really about this whole domain, and we start with Philip Water's talk. Can you stand up maybe? I'm sorry. So later today, Philip will talk about quoted DSLs, which is a very, very general approach and a general idea. about integrating DSLs into host languages. And essentially, if I'm not mistaken, what Philip's point is that you essentially need two things. So you need a way of quotation, which means that there is some mechanism of delineating the DSL terms from the host language terms. And then you need some form of normalization, right, where you can say, okay, I have these DSL terms that sort of the user has written, they are composed together, but really what I want to do is I want to put this into some kind of normal form which actually corresponds to what the DSL syntax and grammar is supposed to define. And I think this is implemented in F#, if I'm not mistaken. And of course, we also have a bunch of talks about embedded DSLs in other languages. So I'm going to talk about embedded DSLs in Scala tomorrow. And so here we're using the type system a lot, right? So we have these specialized types which define, okay, well, this is a regular int or string in the Scala language. And whenever we write rep of int or rep of string, then that means, well, this is actually the same type, but in the DSL. And what we also do is what we call language virtualization. So that means we redefine parts of the Scala language, like conditionals or while loops. We redefine this as method calls. And the benefit of that is that we can use the regular Scala modularity techniques, such as overriding and overloading, to redefine the meaning of an if-then-else. Right? So we can overload this method and say, well, if I have an if-then-else that takes DSL types, then this is going to construct an expression in the DSL as opposed to just executing a conditional in the Scala language. Another talk also tomorrow will be given by Matthew Flatt. I think Matthew is not here yet. Matthew is going to talk about DSLs in RACKET. So that's a different approach. And so RACKET is a dialect of scheme, right? So you would expect that it's really centered around S-expression syntax, right, with lots of parentheses and not really what you would expect like a DSL to look like maybe. But actually RACKET has a completely customizable syntax system, right? And you can start any RACKET file with a #lang directive, and that will define the syntax that is to be used in this file. And the way this works is you just you give it a path, right? And from this path, it will load a processing module that will implement the concrete syntax. But of course, this is all a system based on macros. So all of these things are like redefinable, and you can compose them using macros. And it's a very, very flexible system, really. So you can have parameterized modules, you can have syntax blocks inside files, and mix and match everything and combine these things. So Matthew is gonna talk more about that. Then we have a talk about DSL embedding in Haskell, which is given by Ryan Newton. So Ryan isn't here as well, so he's just gonna fly in from Portugal on Wednesday for his talk. And Haskell, of course, is also a very good language for DSL construction, right? It has a very flexible system which is called template Haskell, right? Which allows you to write code generators in both typed and untyped ways. There's rebindable syntax. You can have type-safe observable sharing, right? So Ryan is going to talk more about what that means, but it's basically in a functional language without side effects. You have the danger of losing sharing in your DSL, which means that you will, if you're not careful, your DSL program might duplicate sub-expression and also duplicate computations, right? So you want to have a structure where you can actually observe when this happens, right? And this is one of the problems that template Haskell solves. So this is more like the front end and stuff about syntax and how things look like to the users. Then on the middle end, the question is also if we're talking about embedded DSLs, right? So how do we build fast compilers for embedded DSLs, right? And there you can use lots of techniques that have been developed over the last decades, like scrap your boilerplate and generalized algebraic data types to make these DSL compilers more modular and composable as well, right? Because you don't want to start with a new compiler for each new DSL here. And on the back end, there's also support for code generation. So there's quasi-quotes, and then there's backends for LLVM and other facilities like that. So finally, there's also some, I would call, new horizons for embedded DSLs. So Johnathan, can you stand up? Yeah. So Johnathan's talk is mostly about reconfigurable hardware, right? So you're writing DSLs like Chisel, and I think the new one is called Clipper, which we can also view as platforms for generating hardware, right? But Johnathan also has done some new work together with his student Patrick on essentially taking the view, okay, well, if we have the liberty of designing new languages that are meant for embedding DSLs, then what would that look like, right? And I think STANZA is one example of that, which also tries to combine the best of scripting and production languages, right? With simple orthogonal concepts and a powerful macro system that is inspired, as far as I understand, by Lisp and Dylan, but also works with more conventional syntax. And yeah, so that's all I have in terms of overview. So I wish you all a great week, and I hope we all learned lots of things here. And yeah, I'm really looking forward to the whole thing. Thank you. Are there any questions? Good, then if not, I'm going to hand off to Markus, who will speak more about performance.